Hello there. So this is a little different technique for filming for me. I've got a tripod set up on my dining room table. I want to try and show you how I'm going to assemble these cards, but let me tell you a little bit about them first. First off, I received from JLC PCB, not sponsored or anything, but that's where I had these manufactured. 10 of these boards. Each of these boards has 40 individual LED holders. They are double-sided that I am going to pick and place myself. So I've already put one of these boards together, and it looks like this. Hopefully you can see that. I'm going to bring it up a little closer, but I'm not sure how well that's going to film. But what you're looking at here is the top side of the board as it would be mounted in our pinball machines. And these little connectors are small crimped down connectors that will hold the power and ground wires. When I designed these boards, I actually placed these connectors a little too close together, so I don't think we're going to be able to use all 4 of the pads with crimped down connectors on it. I have another set of boards that will be delivered as soon as China starts working again from their New Year's holiday, and that should be here in a few days, I believe. And the connectors are spaced farther apart, so it should work better. But in order to manufacture these boards, or to pick and place these boards, I built one of these little fish pump vacuum placement tools. And I'm a little close here, so it's kind of hard to see. But this is just a barrel from a paper-made pin, a needle from a ink refill kit that I bought at one time, some plastic tubing I got at the local hardware store, and a Whisper 40 air pump that I've modified into a vacuum pump. And I'll link to the video I watched that showed how to do that modification with this exact pump. In case anybody's interested in doing that. So what this thing does, it creates a small vacuum, and if you can see right here in the handle, there's a small hole. And now initially the idea was that when this thing draws a vacuum, you can reach down, you can cover this hole with your finger, and that'll allow the vacuum to extend to the end of the needle, and you can reach down and pick up some component with it. Boy, that shadow's in a terrible place, isn't it? I'm gonna have to move my light. Hold on just a second. Okay, I'm not sure you can see it, but right there is one of the small pick and place parts, the little connectors that I'm gonna put down. And so I can cover this hole with my finger, and that creates a vacuum. I can reach down, I can pick up the part, I can set it on the board after I've put solder paste on it, push it down, let go of the finger, and then let go. Now that's a little jiggly. What I discovered when I was manufacturing the first board was that this vacuum is just light enough that I can actually tape this hole shut and have the vacuum running all the time. And I'll show this when I start making the board. So I can have that vacuum running all the time. I can reach down, pick up the part, set it on the board, and the solder paste has enough stick that I can lift it away without pulling it back off the board. So it works perfectly. No extra hand motions. I just grab a part. You can see the parts back here in their reel, and I'll be pulling those parts up and sticking them down on the thing. So I have a solder mask that I purchased from JLC PCB also. They go along with the boards. I'm not going to show putting the solder paste on the boards. There's 100 YouTube videos out there doing that. I was just kind of showing how our little pick and place machine works here. So I'll be back when I have solder on a board, and I will show you putting the parts down. Okay, the solder has been applied to the board, and I'm going to start using my little vacuum pick and place machine to put the components on. So I'm peeling back the tape on my little row over here on the side, and I will start grabbing parts and sticking them on. I'll start with this one I have right here. Oops. And you can see how once it gets into the solder paste, it just holds right on. I need to tape this down. This little mat I'm working on, if nobody's seen this before, when JLC PCB delivers a stencil to you, they pack it inside this little two of these little pieces of hardboard. Two little pieces of hardboard that they used to use to back the circuit boards as they were drilling holes in them. So you can see all of these holes drilled in here all around are all from the manufacturer of somebody's PCBs. And once you have this set up and you get a rhythm going, it's pretty easy just to set them down. Of course, they don't have to be perfect. They will realign a little better once they get reflowed. And I just reflow these in a plain old non-modified toaster oven. I have never done a two-sided board. So this is going to be the first time that I'm trying a two-sided board. Now I need to make sure my hose doesn't drag across there too many times. So when you do a two-sided board manually, you solder down one side, you let it cool, or you reflow one side, I guess I should say. You let it cool, and then you reflow the second side, and the surface tension of the solder will hold the first set of components on even though they are hanging upside down. I have not ever tried this. I have seen it done a few times, well, on YouTube videos, and it looks perfectly easy, so I am going to try it. And I decided to do the connectors first. Since they are not heat sensitive, it wouldn't hurt them to be heated up multiple times. The other side of this board will have SK6802 RGBW LED and the capacitor soldered onto it. So I really didn't want to subject those to reflowing twice, even though if you do it quick enough, it shouldn't hurt it. So as you can see, this is a pretty mind-numbing, repetitive task of just picking up parts and setting them on the little solder bed, picking up another part and setting it on the solder bed, and so on and so forth. The nice thing about using this little vacuum picker is that you can pick these parts right out of their tray that they're shipped in, as opposed to dumping them out on the table and then having to deal with all the parts, laying all over the place. It should be even better when I have the, oops, that one's turned 90 degrees. When I have the LEDs, I can't quite reach to the end of my thing here, so let me pull some of these over a little closer. I do need to make sure that the things are turned in the right orientation. I am my own optic inspection machine, so. Okay, so you get the idea. I'm not going to film all of this. Pretty boring, but I'll bring you back when I got the card completely loaded, and we'll take it over to the oven and reflow. Okay, I have them all placed. That took about 10 minutes. It really doesn't take long at all, especially when you're not having to work around the camera. But so it was pretty easy. I have the power and ground connectors put in. On this one connector right here, sorry for the shaky cam there, I put all 4 of the connectors on. I just want to try it out to see maybe there's just enough room that I could actually use all 4 connectors. So I figured I would try it on one and see if I can get in there. So I'm going to take this over to my toaster oven and reflow it. I'll show you what it looks like when we get in the kitchen. Okay, here is the toaster oven. You can see the board sitting in there. Plain old regular toaster oven. Just close it up, crank the temp up to max, and let it heat up. Now when I have temperature sensitive components on there, I put it on medium, and I heat it for a while on medium, and then I turn it up on high. So I'll bring you back in about a minute or so when the parts start melting on and show you what it looks like. It's pretty dark in there, but I have a handheld flashlight that will illuminate it a little better. So hopefully we can see what's going on. Okay, it looks like they have all reflowed, so I'll turn the oven off and I will allow that to cool down in the oven. Sorry for the flashing light there. There it is, completely reflowed. Everything looks pretty good. I've been looking at this one and I am pretty positive that that is too tight to get the connectors on. So this particular board definitely will not work. The new boards that are coming in are 5 millimeters wider than these boards. So these are 10 mil and those will be 15 mil, so half again as wide as this one, which really spreads out the connectors. And I move the power and ground out to the left and right proportionally also. So those boards will be a lot easier to do. Plus they are a multi LED boards. There's 3 to 5 LEDs per board instead of just one. So there'll only be one connector for between 3 and 5 LEDs. So there'll be a lot less connectors and a lot more LEDs, so that'll be good also, a lot less work on this side. Now when you reflow the second side of this board, you have to put this in the toaster oven supported so that none of these pins are touching any of the wires in the toaster oven. Otherwise, once they get liquefied again, they'll move around. So we want to make sure that that doesn't happen. So I haven't quite decided what I'm going to use to do that. Some ceramic tiles or something, I guess. So we'll have to figure that out. But that'll come later once we get the parts in from China to make the boards.